Hey guys, welcome back. So this is the third and final lesson for this week. So we'll go ahead and jump right in. It is more about polygons, a specific kind of polygon. So last time we were looking at a specific polygon known as the triangle. This time we're looking at specific polygons known as quadrilaterals. So our four-sided figures. So a quadrilateral is any polygon with four sides. Quadrilaterals can be classified by their angles or pairs of sides. So we're going to run through, we've got a lot of things to run through, definition and property-wise and everything, so just bear with me. So, parallelogram. Both pairs of opposite sides are parallel and equal in length. So, my little arrows on here, that shows that these two sides are parallel, meaning they're never going to intersect. Same with these two sides being parallel and never going to intersect. They also would need to all be the same length, or opposite sides would have to be the same length. Next we have a trapezoid. So a trapezoid only has one pair of parallel sides. That's the difference between parallelogram and trapezoid. Trapezoid has one pair of parallel sides. Parallelogram has two pairs, or both pairs are parallel sides, opposite parallel sides. So, two different examples of trapezoids for you. Next, we move on to rectangles. So a rectangle is a parallelogram, so it's a kind of parallelogram that has four right angles. So you guys know what rectangles look like. So it has to have those four right angles. The opposite sides are parallel, and they're congruent. So these two sides are congruent, and these two sides are congruent. They're also parallel. Rhombus. A rhombus is, once again, a kind of parallelogram. So it's a parallelogram that has four equal sides. So this time, the angles aren't all the same, but instead the sides are all going to be the same measure. So they all have to be 4, all have to be 10, all have to be 100, whatever the case may be. The angles don't matter so much. But once again, we have two pairs of parallel sides that are congruent. And last but not least, we have the square. So a square is a rectangle with four equal sides, which means it's also a rhombus. So a square is both a rectangle and a rhombus. So all four sides are congruent and all are the same, and all four angles are 90 degrees. So they're all right angles. So there are our different kinds of quadrilaterals. These are special quadrilaterals. So finding the number of parallel sides in a figure helps us determine what kind of figure we're dealing with. So how can you find the number of parallel sides? Step 1, quadrilaterals with pairs of consecutive. Consecutive means next to. So I am consecutive to this board because I am next to this board. So consecutive equal angles will have one pair of parallel sides. So if we look at the picture here, we have 132 and then 132. Then we have 48 and then we have 48. These two angles here, these are consecutive, and the angle measures are the same. Same thing with this, 48 and 48. These two angles are consecutive, and they're also the same value. So that tells us we just have one pair of parallel sides, and that would be those two sides, which means this is a trapezoid. All right, so if that wouldn't have been the case, if we wouldn't have found that consecutive, or angles that are next to each other, were equal, then we'd move on to look at step 2. So quadrilaterals with pairs of opposite equal angles will have two pairs of parallel sides. So opposite just means they're on opposite sides. They're in opposite corners. So if we look down here, we have 80 and 80. That's supposed to be an 80. Or no, it's a 70. Sorry, I can't read my own handwriting. 70 and 70 and 110 and 110. So the opposite angles, ooh, this is really hard. Opposite angles are the same. So think about it as an X. If the ones that form that X are the same, then you know you have two pairs of parallel sides, which means it's a parallelogram. So those are a few of the different properties about our quadrilaterals. Quadrilateral is your keyword for this lesson. So like I said, these are what are known as special quadrilaterals, because obviously we can have four-sided figures that aren't necessarily a parallelogram, a rectangle, a square, a trapezoid, or a rhombus. So how are special quadrilaterals related to each other? This family tree shows how special quadrilaterals relate to each other. So quadrilaterals is up at the top. We have a kite, which we haven't really talked about. Don't worry, we'll get to that later on when you're in 6th grade. We've got a trapezoid, and we have a parallelogram. So these are 3 different types of quadrilaterals, special quadrilaterals. Then off of trapezoid, we have an isosceles trapezoid, which just means that the 2 sides that aren't parallel are congruent to each other. So it has 2 sides that are congruent within that trapezoid. And then last but not least, we have parallelogram. From parallelogram, we split off into a rhombus and a rectangle. And then from both the rhombus and rectangle, we get to the square, because a square is both a rhombus and a rectangle. So each branch of the tree shows a subgroup of the figure above. So we have all these different subgroups, obviously, as it extends out. So the square is a type of rectangle. So that's how we can see that, because it comes from the rectangle. We know that it's a type of rectangle then. And all rectangles are parallelograms, because it's a subgroup of the parallelogram category or branch. So each figure shows all the properties of the figures above it. So a square and a rectangle have 4 right angles. So a square is down here at the bottom. That means everything above it, it shares. That means it shares the fact that a rhombus has 4 equal sides, that a rectangle has 4 right angles. It shares the fact that a parallelogram has 2 pairs of parallel and congruent sides. And it holds with the fact that it's a quadrilateral, meaning it has 4 sides to begin with. So it has all the properties up above it. Just like an isosceles trapezoid is going to have the same properties that a trapezoid has, it's just a little more specific. Alright, so what you guys are going to see for your homework is going to be statements and different properties, and you have to figure out what goes with what, and some true-false statements based off of this tree and the relationships. So, all squares are rectangles. Is that true? Yes. That is true. Are all rectangles squares? No. My guess is some of you were about ready to say yes. But rectangle comes above square in our tree, which means it's not always going to be a square when we have a rectangle. So, false. So, be careful with that. That catches a lot of people when they're trying to figure that out. Remember, your keyword for this lesson is quadrilateral. It's all about the different properties and the different kinds of special quadrilaterals that we have. All right, have a wonderful week and happy mathing.